Welcome to this session of webinar on analysis using open source utilities, where we'll be discussing and focusing on Windows artifacts. So my name's Naveen, and let's do this. So before going into Windows artifacts, let's discuss what's a basic things like what's a disk forensics. So basically, disk forensics, it's a branch of digital forensics, and it will be mainly focusing on collection, preservation, examination, analysis, and reporting of any data that is present in a storage media of the computers. We're not talking about any mobiles, okay? We'll be focusing on only computers and other systems. So these storage media, they can include like hard disk, they can include like SSDs, and any other pen drives or any flash drives. So all these can be involved in storage media of computers. So next, this disk forensics, it can play a crucial role in various domains, and it can be helpful in for various sectors also. So the main three sectors are criminal investigations, cybersecurity, and corporate investigations. So in case of criminal investigations, as you might all know, like whenever there's an attack from a hacker or any cyber attack, here it can be this forensics can be very helpful, like locating like what's the basic what happened actually, how it was compromised, and all these, like what's the digital footprints also we can get. So by using all these, it can be very helpful in forensic investigation. So in case of corporate investigations, we'll be looking at some internal investigations within organizations. There can be any misconduct of any employee inside a company, so like insider attacks on all these. So in that case also, this forensics can be very helpful. So let's look at what are the basic, like what's a basic type of digital evidences. There are basically two. We'll categorize them into two first. So one is volatile data, second is non-volatile data. What is volatile data? It is a temporary data that will be residing in the system or in the storage media. Hello, am I audible? Okay. So volatile data, it is a temporary data that will be residing in the system when the system is actually in on condition. So whatever the task or whatever the process that is going on in the system will be stored in the RAM, random access memory. So this, when as soon as this system goes into power off mode, all the volatile data just gets volatilized like that. So next is non-volatile data, and just you can guess, this is a permanent data which will be residing in a storage media like hard disk and SSDs and all these. So it has nothing to do with whether it is system is on or off. The data will be there anyway. As we move along, forensic processes. So we'll discuss very briefly about SOP, standard operating procedures. So the first and most important starting step of SOP in digital forensics is identification of any digital evidence. So first we have to identify like what's the digital evidence that is actually has actually a potential importance in a investigation process. So it can be anything like hard drives, it can be SSDs, USB drives, or if the system is on it, anything RAM dump or anything. All these things can be a digital evidence depending on the case. So next, as soon as we identify the evidence or digital evidences, so next we have to do, we have to preserve the evidence. So that the main point of preserving the evidence is maintaining the integrity. So in digital forensics, one of the golden rule is like integrity maintenance. So preservation is mainly for maintaining the integrity and letting it not to get altered or destroying the data, whatever it is present inside that evidence. So for that, we'll be making forensic copies, either cloning or imaging, or there are other ways also. So yeah, we'll be making the copies and we'll be working on those copies, not working on the original evidence. So next is analysis. This analysis step includes both examination and whatever the data that is residing inside the storage media will be retrieving that information as well, and will be analyzing that information as well. So it can these data can be like a metadata also, or any hidden data, everything, whatever everything whichever has a potentiality of being an evidence. So that will be analyzing here. And next is documentation. Yeah, so whatever we were doing with the evidence, everything should be get documented, as we know, as we have studied in forensic basic things. And next is reporting. So after everything was done, and we'll be making a report, and we'll be submitting that report in the court of law. So then our work is done. So here we'll be bringing up a new topic called triage. So generally, triage means narrowing down the things. So in case of when we talk triage in digital forensics, so basically what it is like, we'll be prioritizing all the events that has happened, that had already happened in a crime. We'll be prioritizing everything in a way, in an organized way, so that it will be very helpful, and it will be very it will make the investigation process very simple. So as you can read here, like the goal is to quickly identify and categorize potential evidence, allowing investigators to determine the scope and direction of investigation. So it is a process where investigators collect, assemble, analyze, and prioritize the digital evidence. So this is a process of triaging, and there are various tools for triaging also available. Some are open source, some are commercial. So we'll be look at that. So next, let's go into our core topic for today's webinar, which is Windows artifacts. So what's are basically Windows artifact? Windows artifacts are any objects that present in a computer, which are actually created by using an operating system, or while using the system, which can hold potential user activity and system activity. All these things will be inside a Windows artifacts. So these are basically the data remnants, and these Windows artifacts can play a huge role in digital forensic investigations. So there is a lot of forensic significance when we talk about Windows artifacts in digital forensic investigations. Some of these things are NTFS timestamps, uh, NTFS timestamps, where it will be where it will show MAC timings, MAC MAC timings, which are modified timings, modified time, access time, and created time. So these three things will be calling them as MAC timings, or else NFS timestamps. And next, user activity tracking. We can track the user activity also, like whatever the things that a user has done in a particular system. So all the activity that will be logged in the system, of course, in a form of various artifacts. And system activity tracking and malware. Yeah, this is the main thing, malware analysis. So whenever a malware is infected, and through which path the malware has been infected, and what sort of action did the malware took. So all these things we can be analyzing through Windows artifacts. So let's take a look at various Windows artifacts. There are actually a lot of Windows artifacts. So in this session of webinar, we'll be looking at some of them, and we'll be looking in a deep down. So first thing is metadata. Metadata, it's in simple words, it's data about a data. There will be so many files. So any data about a particular file is a metadata. So this metadata can include like what's the file name, what's the file size, what's the file path, and size on a disk, and its original file size, and its modified time, its created time, its access time. So all these things will be included in the metadata. And for checking the metadata, simply you just have to right click on a particular file of your interest and go to properties, and it will be showing all the metadata that is available. So next is EXIF data. EXIF means exchangeable image file format. So this EXIF data is in a way you can say this as a metadata about particular pictures and multimedia. So when we talk about images and videos, pictures and videos, so they'll be having a extra amount of data that will be categorizing as a exif data. So this exif data will be consisting of so many potential things. First thing is camera settings, device info, geolocation data, date and time, authorship of image, and particular which phone have you used, and also what kind of camera settings, what's the ISO, what's the exposure, what's the AF, what's the EV, what's the shutter speed, what's the shutter time, and all these things. And if the user has created a name for a device, so that will be also visible. So these all comes under exit data, and next is prefetch files. So prefetch files, these are basically a memory management scheme. So basically what happens is whenever you open any application or any file, a prefetch file will be created associating with the particular main file. So why this happens? I mean, why is there a need of creating a prefetch file? So basically, it's for optimizing the loading of frequently used programs. So this means like uh, whenever we try to open a see a particular app multiple times, like I opened a app right now, and after some time I closed it, and again I want to open it. So the second time whenever I'm opening the app, so it will be loading very fast into the system, because it will be fetching the prefetch file directly, which was previously loaded, and not like whenever we click on a particular application, and every time it won't be going to the main file and loading that main file. It takes a huge amount of resources. So this is a basically for optimization purpose. So prefetch file extension will be a .pf, and its prefetch file location will be in C, Windows, and prefetch, where you have to give the administrator permissions. So it can contain information like timestamps, file access pattern, last run times. Also, you can check for like last 6 or 7 run times, depending on the tool which you pass. So and run times also, how many times have you run the particular application, and volume device information, how much volume it is occupying, on all these things you can identify in a prefetch file. So next is shellbacks. Shellbacks, it's basically view preferences of a user. Like whatever the UI user interface that has been set by the user will be stored in the form of shellbacks. So these shellbacks will be located within the file named ntuser.dat. As you can see, ntuser.dat, it will be present in a registry hive, or you can either access this in, you can either see this file in registry hives, or you can either see in a file explorer also. I'll show you where to locate the end user or that. So there are two things again here, like end user.dat and user class.dat. Uh, these both will be almost for the same purpose, and in different versions basically. And they will be revealing the information basically about timestamps, the main thing, MAC timings again, modified access created timings again, and folder access, like which folder was accessed, and evidence of folder deletion if there was any folder deletion and the person is denying the fact that he deleted the folder or deleted the application. So yeah, this also we can check whether a particular folder has been deleted, or overwriting, or renaming. So all these things, as you can see here, whether I use user accessed a specific folder, whether a folder was created, all these things you can just get the info from the shell banks. So next will be LNK files, or link files, or basic we can call it as LNK files. So these are basically shortcut files of any application of or any file. These are let's say you have installed an application, and whenever you install an application, you have a chance of creating a shortcut on the desktop. This shortcut is nothing but a LNK file, link file. So whenever we're trying to open the shortcut, it will be directly linking to the main application or main file as main associated file. From that, it will fetch up all the information and it will load the file. So again, this extension will be .lnk, and it can hold up potential information like original file path, where the original file is residing, and timestamps for both files, and the size of target file and MAC timestamps. All this we can get to see. So next is page file.sys. Page file.sys is basically, I'll tell you in the simple words. Whenever we're using we're overloading, we're trying to overload a RAM, or we're running so many tasks or process in a particular system. Let's say I have a RAM of 8 GB. So we started running so many process which actually took the whole 8 GB, which actually occupied the whole 8 GB, and still we want to run a 2 or 3 more processes or tasks. So what happens is the system will be creating a virtual memory in the hard disk itself. Hard disk is a non-volatile memory, I think so. So it will be creating a virtual memory section in a hard disk where where the all the tasks that are running in a system which were like not recently used, or which were not immediately needed for the system. So these things will be stored on the virtual memory, and the new process that we want to run, that will be stored on the RAM again. So this is basically a memory management scheme. So it can hold information like all the process what are running, and passwords, documents, evidence of any, if there's any malicious activity, if there was any malware infected into the system. These also we can get to know from page file. And any timestamps, file paths, file name, network connections, registry keys, command history. So yeah, all these things we can see from the page file. And this page file, we can see its location will be in a C drive only, in root by it should be a root user, like providing root access to the C drive. And also you have to give, there is a particular setting called hide protected operating system files. You have to turn it off. So in this way you can see the page file. Just a second, just give me a second. Hello, am I audible now? Can someone please let me know whether I'm audible? Yeah, okay. Thanks, Christian. Thank you. So can you just let me know from where it was not audible? From which point it was not audible? Can you please let me know? File, page file. Okay. Okay, then we'll be starting again with the page file. Yeah, so page file. So what's a page file? Basically, it's a virtual memory management thing. Like let's take a RAM. Let's take a case where we are running so many processes in a system, and the whole RAM was completely being used by all these processes of task, whatever it is. So still we want to open few more tasks, or we want to open few more applications. We want to run some more processes also. So in that case, what happens is uh, the system will be creating a virtual memory section in the hard drive itself. Just focus, I'm not saying RAM again, I'm saying the hard drive. This virtual memory will be present on hard drive. So uh, whatever the task that were being not used as of now, that will be stored in the virtual memory. And the new tasks or new processes that we want to run right now, that will be taking into the RAM itself. So it is a in this way memory management scheme will be done. So, and this can be used, this is basically for freeing up the physical memory for performing other tasks by temporarily storing the data that isn't immediately needed. Whatever the processor, whatever the task that we don't need right now, as of now, not that important, that will be stored on virtual memory as a name of page files.sys. So this page file.sys, it can hold a potential information like process, what are all the process running in the system right now, that was being stored in a hard drive virtual memory, by the way, and what are the passwords, documents, or either if there's any malware infected or malicious activity by a malware, or any timestamps or file paths, network connections, yeah, so etc. Like so many things can be stored in the page file.sys. And how to view this page file.sys? Yeah, so it will be stored in you can view that page file.sys in a C drive itself. But the thing is, like, you have to get a root access, and also when you go to folder options, and in the view section, there will be option called hide protected operating system files recommended in brackets. So you have to turn it off, and it will be a prompt of like prompt of a warning, like it can be deleted. So when you turn these off, then the page file.sys will be appeared on the screen in a C drive itself. So next is hibernation file, or simply hyperfile.sys. So this is also almost like a same thing as a page file.sys. It will be stored in the same location. But the thing is, like, whenever we performing any task or any process is running, just take an example of you watching any video or you're playing some game, and suddenly you got some other work. So you'll be just closing your laptop like that. So it will be going into a sleep mode. That sleep mode will be, we can call it as also hibernation mode. So whenever the system goes, as soon as it goes hibernation mode while watching let's take an example of watching a movie, and you close the laptop. So the process that were running till that particular time will be the system will be taking a snapshot of all the process, and it will be paused till that particular time. And whenever you reopen the laptop, or you open your laptop and you take it out of sleep or hibernation mode, so again the processes will be resumed or continued from that particular point of time. So this is also basically one of memory management scheme. And system resume from the same state, the wherever the system has stopped or paused, it will be resuming from the same point of time. And these hyperfile.cs, it will be holding such type of information like logged in users, who are all the users that are logged in the system, and active user applications and open files, and network connections, timestamp things, again same things. And it can also hold a particular information like any malicious activity that was being done at that particular point of time. So it depends on case to case again. So next is shim cache. So this SIM cache, it can be also called as app compact cache, or SIM, or originally it's called as application compatibility cache. So application compatibility cache, it mainly holds the information of whatever the applications or whatever the executables that were being run, or that were run at a particular time. So all information or data regarding all these apps that were being run on the system. So these all information data will be stored in the form of SIM cache. So this SIM cache will be, you can view these in registry hives, as you can see on the screen. So there is a path to the whole SIM cache. You have to go into H key local machine and system current control set, control session manager, app compact cache. So it can be, SIM cache can be helpful in identifying particularly timestamps. Timestamps is the main thing in SIM cache while we're talking. So file names, file paths, and file size also. And when was the last update of Cache, we can be getting the information of this also. So next Windows artifact is amcache. Amcache is or else amcache.hve or Hive. So this is also app related, application related Windows artifact, which actually stores whenever any application or whenever there is a executable that was being installed or run on the system. So this amcache will be having the installation timings also. So focus on this. When was the app installed on the system, was it run, and yeah, these all things we can will be getting from amcache. And the location of amcache will be in C drive, Windows, App Compact, and programs. You can get the amcache file directly, amcache.hve. So it can be helpful in identifying timestamps, execution path, file size, volume, serial numbers, installed version, what's the installed version of a particular application, and of course a hash value, which is actually very important for us. And next is USN general. So this is one of the Windows artifact that was created since the introduction of NTFS file system in Windows. So it maintains as you all can guess, like a general, what's a basic general, it maintains all the logs, like whatever that is happened in a system, everything will be maintain records, and it will be store all the records in a system. So it tracks all the changes in a files or directories. And whenever I say it tracks all the changes, it doesn't mean like whatever the changes that was being made in the file or in the content of a file, that won't be stored. What actually stores is file metadata. If there are any changes in the file metadata, or if the file, if file was being created, if the file was being deleted, if the file was being overrated. So these kind of things will be changed, will be sorry stored. And you can get like whenever you want to try to access this user general, so you can get the past 7 days of general, all the records that has been changed or that was done in a system last 7 days. Sorry. So yeah, the importance of this USM general is suspected file that no longer exists in a file system or MFT. If they if the user or the criminal might be like thinking like he just deleted the main file, so he thinks like, yeah, everything is deleted. But it can be logged or it can be recorded, records of that particular file which he deleted, that can be present in the USN general file. So it can be very useful in that way. So next is jump list files. So these jump list files are nothing but whatever the recent files that was being used or accessed in a system. Recent files. You can simply say recent files. So whenever you open multiple apps in a taskbar, there'll be so many apps open in a taskbar, and whenever, just let me show you. See, so I have opened, right click on any application, and you can see these are all recently closed. So these are nothing but jump list files. All these are whatever that was being recently accessed. So all these will be recorded in jump list. And if you want to check another one, see, these are all jump lists again, which are pinned to the taskbar, which are frequently used, which are recently used. So all these things will be stored in the form of jump list files, and its location will be in an app. C users, particular user, and app data, roaming, Microsoft, Windows, and recent. In the recent folder, you can find all these jump list files in the name of shortcuts or recent use files. So timestamps of when items were accessed can be known from this jump list, and application specific actions, like whatever the, if there is any action or if there is any process done related to a particular application, that will be also recorded in the form of jump list. Next artifact is USB plugin and play. So whenever you install or whenever you connect any pen drive or any any device, any physical device to a USB port to a system. So the system will be maintaining logs of whatever the devices that were being connected to a particular USB port also. So in that way, it will be maintaining all the logs of the system. So you can access or you can view this USB plugin and play in registry hives. So the location was being shown on the screen, and when you try to view this in registry editor or reg edit simply, so it will be appearing like this in this snip. As you can see, USB store and all these things that was being connected in this particular system. So yeah, till now we have seen like various Windows artifacts till now. So right now, we'll be looking at the tools, some of the open source tools, which is our one of the main topic. So open source tools and how will be and Windows artifacts. So these are the open source tools that currently I'll be showing you in this particular webinar. So first is Eric Zimmerman tools. This is a repository of huge tools where you can just simply go to Google and simply search for Eric Zimmerman tools. And next is Nirsoft, which is also one of the open source tool, and it is basically used for triaging purpose also. And Regripper, you can use this Regripper for passing or for analyzing registry hives. And Autopsy, of course, Autopsy has almost everything whatever you want in this forensics. Autopsy can do anything almost. So it's one of the best open source tool from. I mean, that actually my opinion. So let's see about Eric Zimmerman's tool right now. Just go to Google and search for Eric Zimmerman tools. See the first link. Open the first link. Yeah. So this is how it looks inside, and so as you can see, these are all the forensic tools that are available, and different versions of those forensic tools and their purpose, what are they used for. So in this session, I'll be doing some practicals on prefetch prefetch files and event logs and LNK files. Also, I'll be showing you how to pass these into these Eric Zimmerman forensic tools. So you can just directly download whatever the services or whatever the utilities that you want to run. You can just directly download by clicking on these versions. First, let's look at a prefetch parser where we'll be parsing the prefetch files. So you can just simply click on this version number and it will be downloading the version. So I have already downloaded. So I'll just show you how it works actually. So yeah, this is my particular application, the prefetch parser. So for this, we'll be opening a command. All these tools that I have shown you in Eric Zimmerman repository, these are all command line based. So it's actually not much difficult. Anyone can use with some basic knowledge. So first you just have to run the command prompt as an administrator. Then only you'll get to do all these things. And just go to the particular path where the application is present. So yeah, this application, it is present in D drive. So right now I'm in the D directory. So next we'll be running the prefetch files. Let me just copy this particular application path and just paste it here. So this is your application path. Next, there are a few ways for analyzing. Let me show you that also. So see, as you can see here, all these options are available for particular things. If you want to process a single file or particular file of your interest, you can use F, or if you want to take for the whole prefetch folder, you can use a D. So in this way, and for output, you'll be using a O. So in this way, you can use options which you want, depending on your purpose of using. So right now I'll be taking a particular file only. So fetch, let's go to prefetch folder right now. Yeah, you have to give the administrator permissions for sure. As you can see, all these files, there are so many files. So all these are prefetch files, .pf files. So I'll be taking, okay, let's take this particular file, copy its path. Yeah, just copy the path of the particular prefetch file you want. And if you want to save a report also, then in that case, you, right now I want to save in, there are multiple options of saving a report. So in JSON file, JSONF, CSV, CSVF, HTML format also. So in these ways, you can just create a report. So right now I'll be making in a CSV format, and where I want to save this particular report. So that for that I'll be giving a particular location. Okay, let's choose this. Copy its path now. Just paste it. Next, just click enter. Just a second. Yeah, so the process was done. These are all the steps that was involved in this process. So let's directly go to our particular file. So these two are the files that has been made right now. These are the reports basically. Yeah, so as you can see, these all particular information will be related to a particular prefetch file which I actually took. So this is the source file location. You can just see this also. When was this source created? This created timestamp is visible right here, and source modified also you can see, and source accessed, and what is that executable name? This is that executable name of a particular prefetch file, and the hash of a particular file. Again, the size of that file, the version it is running, and how many times has it run till now, run count. This is one of the main important thing for us. Run count, it was in my system, it was run for like 327 times. And last run, when was the last run? This is the last run. And here we can see the previous runs, previous run 0, previous run 1. So in that way, 6 times. Yeah, previous run till previous run 6, we can actually get to know all these timings and everything. And the volume serial numbers will be visible there. So all these things, in this way we can use this prefetch parser to get so many things, and it can be very useful depending on the case also. If you want to check for a particular application, or check for a particular malware injection, or any prefetch file you got, you can just simply pass it in the using this command tool, and yeah, your work is done. So okay, right now we'll skip to event logs. So again, the same thing. Let's go to our command line. Again, we'll be doing the same thing. So wherever the application was installed, just open that. Yeah, so this is the event log utility that was being offered by Eximoman tools. So you can just download it from here, and I have downloaded already. So it is, yeah, here it is. So this is the main application. Again, the same process will be involved in this also. Just copy the path of this file first, paste it here, and just remember to be in the same directory where the application is located. Okay. So next is same F and particular these event logs. So right now we have to check the event logs. These event logs will be present in C, and go to Windows. Next, system 32, and in this you can check for WinEVT. Yeah, see, as you can see, in the logs folder, all the event logs has been stored. See, these are all the event logs. So we'll be looking at a particular, which should we take? So let's take the first one in the application. Just copy its path again and paste it here. And next, again, I want to make a report of this also. So again, the same process, the CSV and the path where I want to store this uh, particular report. So I want to store this in the same. Okay, let's give the same folder. So now let's take this. So right now it is running. As you can see, the process is going on here. Visible? Yeah, so the process is done. And let's go to our report. Open this report. Yeah. See, all the event logs that were particularly related to application event log, all the files associated with that particular log will be given here. There are you can see the record number, event ID also you can see, and the created time. So here you can see the created time, and the event ID is visible here, and level error. So these are actually this error. It actually signifies that any application that was actually gave a prompt of error or any error prompt. So all these application, all these errors that were being given up when a application was run, all were recorded here. And you can also see some other things like info, these info and warning signs. So these are basically levels which the system actually categorizes into, like error, info, warning, and all these things. Log always. So and also like from where it took the all these files from application event log, it took all these it fetched all these files. That also we can see the process ID, the thread ID, particular applications thread ID we can get, and the laptop, sorry, the computer's default name also can be visible, and these chunk numbers. So in this way, it can be used it can be utilized for examining like so many useful things. And also these databases, wherever the databases that were being particular application was being running or stored, the event logs were created, all these things we can see. And this shows us the username, particular user which has used that particular application. So like this, we can get so much of useful data, and it can be very helpful in particular cases where we want to actually look what are the logs of the system, whether there is a malware infected in the system, or there was any file deleted from the system. So in the all these cases, event logs can be very helpful. Just a second. So yeah, next we'll be looking at the link files, LNK files, like how we'll be passing the LNK files. So again, the same thing. Yeah, you can use these pass link files for passing these shortcut files. You can use this particular link to download the app utility, and I have downloaded. Let me show you. Yeah, so here it is. And again, let's copy the path of the particular executable .exe. Paste it in this here. Again, next we need to give the particular. We need to give the input of particular LNK file which we want to analyze or pass. So for this, we have to go into C first, and it will be in users, in main user, and in app data, roaming. Go to Microsoft and go to Windows. Yeah, here as you can see here, it is the particular LNK files or recent items in the name of recent items. So these are all the shortcuts. These are all the shortcuts that were being saved in the name of LNK files, or okay, shortcut. You can simply say shortcut files. So let's take a particular shortcut file. Okay, let's take this one. This one seems interesting. Copy as path. Just give the path. Just a second. Okay. Again, I want to create a report here. So the same process goes around. I want to store this in. Should I store it now? Okay. Let's be talking about log files. I mean LNK files. Sorry. So we'll be storing in that particular. Yeah, we'll store it right here. And just hit enter. Yeah, it was being done. CSV output will be saved to this directory. So we'll be looking at that right now. Yeah, here is our report. Yeah, again, so here is all the information that is linked to particular shortcut file. Just with a simple shortcut, 1 KB simple shortcut file, we can get all this information. So yeah, of course, it will be such a huge asset for us in digital forensics. The created time, the modified time, the access time, and when was all these created, the particular file size also, relative path also, where this relative path, as you can see here, where is the, I mean, the main location of the main file, that it's been shown here, and right now the working directory. So yeah, all these things and many more. File attribute archive. So yeah, as you can see, there are like so many things you can use this for. Yeah, machine MAC address also. This is one of the main. I mean, of course, it will be so useful if you just get a MAC address. You can just physically identify any machine with a MAC address and machine ID. So all these things you can be identifying by a simple shortcut file. Simply passing a shortcut file in a command prompt. Yeah. So uh, next we'll be looking at one of the famous tool, which is NetSoft. Some of you might have heard about this NetSoft. So it is one of the most common tool which is used for triaging purpose. So yeah, this is the executable file. We'll be opening this. Yeah, so as you can see, there are so many utilities available, like so many. Depending on the case, you can, if you want to check for web browser tools, you can use this particular utilities, or password related, you can use this, or system related, you can use this. So right now we'll be looking at some jump list files. So you just have to find the jump list viewer. Yeah, here it is. This is a utility provided by NetSoft for a jump list viewer for viewing the jump list. Just simply double click on it. Yeah, just give it some time for loading. Okay, let's look about shellbacks actually. We'll look at shellback viewer. Once open this shellback viewer, and yes, so it will fetch all the shellbacks that are present in the system. So these are all the shellbacks as you can see. So what's the shellback again? So these are view preferences of a particular user. So just try to open a particular one, and you can check some of the details related to that particular shellback. As you can see, it is the view mode of a view preference of a user and its icon size. So these are basically it has a significance for in this forensically also. So see, let's take a scenario where a criminal is trying to deny the fact that he deleted a particular folder or he deleted a particular application. He's trying to deny that, and actually it is not available on the basic system also. But if we find, I mean, there is a chance of finding that particular shellback of a particular application which he has deleted already. So whenever application is deleted, it doesn't mean that everything related to it will be get deleted. So in this way, the shellbacks can be used for proving the criminals wrong. You can just give a proof of you have used this, or you have done this activity in the system by using the shellbacks. So yeah, in this way you can do this. And next we'll be looking at a tool called Reg Ripper. So which is useful for registry hives, weaving the registry hives. Registry hives is one of the most important aspect in a digital forensics. So it can hold us like a lot of potential information. So yeah, this is the main application, Reg Ripper. You can just simply download it from Google. It is an open source tool. Simply go to GitHub and get a. I'll show you just a minute. Reg Ripper. Yeah. So just go to GitHub and just you can just download the zip file from here. So just open this application. Yeah, so as you can see, this is the main UI of Reg Reaper. So first you have to give a hive file, which is registry hive. You have to give a registry hive, and you have to give a destination path also. So we'll be giving a. So okay, we'll be giving the particular hive. Yeah, see. So ntuser.dat is one of a registry hive. So let's give this. Let's give it a destination folder also. Where should we save this right now? Okay, we'll save it in a different one. Let's name it as test. Okay, just repeat a part. Yeah, the process is being done. Yeah, so the process was done. So let's look at what's the report has, what kind of report was created. Yeah, so this was the particular report that I just created right now. Let's open this. It is in the format of a text document. So it will be in readable format. So whenever I mean, you might have, everybody might have known that you can just view all the registry hives in the using regedit. Whenever you try to use regedit, you can just only view all these things, but these will be not in any, like readable format. So for viewing these in a readable format, it's better to use Regripper kind of open source tools. And yeah, as you can see, it's like totally extensive report, related to this particular empty user.dat. So here we look at what all the information we got from this empty user.dat. What was the last write time in the system, and all these applications that were last write time at this particular point of time. These all files were being last written. We can identify, I mean, if you have any particular file of interest, so we can identify that also using this retriever and giving a particular high file related associated to it. See, these are all the files that were recently being or last used. All these files and all these paths where these files are located. These things also we can check and verify. Like whatever that was being done, simply I can everything was being recorded and created a logs in form of logs. So everything whatever I do in my system will be recorded in such way. Yeah, so all the app key entries and application paths, all the timings on particular application paths were given here, and caches of a particular file, all the caches. Here are all the cache files. And we can also, yeah, we can also see most recently used list. So whatever the app files or whatever the applications that were being most recently used, MRU we call it as. So that also we can examine, analyze here. These are all the MRU. First folder, last visited, MRU, last rate time, MRU. Yeah, so such way you can, like it's up to your patients actually. If you want to check all the things that was being done in your system, yeah, you can check almost like everything that was being done, everything, literally everything. So it can be very helpful. So yeah, that concludes our this session.
Thank you for watching the webinar. Subscribe to Third Eye Techno Solutions for more insightful webinars and content.